Nadia ma'am, your mic is in mute mode, ma'am.
Yeah. Sorry. Thank you, ma'am. Hello, good morning to everyone. Welcome to today's faculty development program. I request Mrs. Kalista Bibi, Assistant Professor, Department of Computer Science, to give the welcome address.
Yes, ma'am. Thank you, ma'am. A very good morning to one and all present here. I'm happy to welcome all participants for second day of faculty development program. I'm very much delighted to welcome our day 2 resource person, Dr. B. Akila. Madam will conduct this session on topic natural computing ideas and challenges. I would like to welcome our principal, Dr. V. Uma Devi, Head Department of Computer Science, for organizing such a wonderful 3 days faculty development program on emerging trends in computational research. And now I take this as a privilege to welcome our day 2 resource person, Dr. D. Akila, is an academic professor well specialized in computer science domain. She is currently working as an associate professor in Department of Information Technology from School of Computing Science, Wales Institute of Science, Technology and Advanced Studies. She has completed her postdoctorate fellow in computer science from Lincoln University College, Malaysia. She has 13 years of teaching experience in both UG and PG level. Her research interest includes data mining, big data analytics, cloud computing, image processing, knowledge-based system, and web information exploration. She has produced 2 MPhil scholars and 8 PhD research scholars are pursuing under her guidance and supervision. She is actively involved in various reputed professional bodies members like International Association of Engineers, member in Computer Science Teacher Association, and as a member in International Society for Research and Development, World Academy of Science, Engineering and Technology. She has published more than 40 research papers in various international journals such as Springer's, Scopus, and UGC referred journals. She has authored 4 books. She serves as an editorial board member, technical committee member, reviewer in many international journals of Springer. She serves as an international committee member towards international conference conducted in association with IEEE, Springers and Scopus. She has received her Lifetime Achievement Award towards Outstanding Contribution in Education by National IT Cybersecurity Research Association, Government of India, and also Excellent Teacher in Information Technology, Global Out Research Education Award in 2019 from New Delhi. With this introduction, I would like to welcome our Day 2 resource person, Dr. D. Akila ma'am. Welcome ma'am.
Thank you, Mrs. Kalista Bibi ma'am. And Dr. Nadia ma'am, thank you so much. Okay. Shall I
Thank
start
you,
now?
ma'am.
Yes ma'am,
Yes,
yes ma'am.
ma'am.
You can start this session.
Okay. Thank you. Thank you. Fine. At the outset, Thiru K. Loganathan, respected Chairman, Mr. I. Naveen Prasad, Vice Chairman, respected Dr. M. Prabhakaran, Director Admin, Dr. V. Karnanidhi, Director Admin, respected Dr. V. Uma Devi, Principal Madam of New Prince Sri Bhavani Arts and Science College, the faculty members of Department of Computer Science and IQAC, and the faculty members of different colleges and universities who came here for participating in this FTP, virtual FTP on emerging trends in computational research. A great morning and warm regards from Dr. Akila. Good morning, one and all present here. Yes, hope you're all fine and doing good. Yes,
Good
fine.
morning, ma'am. Yeah, fine, ma'am.
Yeah, thank you. Okay. First of all, I'd like to congratulate the Department of Computer Science and Accuracy for organizing such a wonderful that is FDP through this virtual mode on emerging trends in computational research. Actually, we people, that is most of the people or FDP, that is faculties here, I think so. Maybe a few research scholars may present in this session, but most of them, it is according to me, 80% of the participant may be from a faculty side only. So we should feel proud about ourselves, because in this pandemic situation also we are doing our duty without any breakups, and we are taking the students to the next level without any interruptions. So what to say, so everybody is, that is நம்ம சொல்றோம் இல்லையா, ஃபோர் ரன்னர்ஸ் அப்படின்னு சொல்றோம் நம்மளோட. இவங்கெல்லாம் இருக்காங்க, டாக்டர்ஸ், நர்ஸ், அவங்கெல்லாம் இருக்காங்க. ஸோ தே ஆர் டூயிங் their டியூட்டி in a great way. They are very close to corona, that is COVID 2019, and now it is going to be to 2021, and again we are going to face in 2022. The people are that is doctors are telling the third wave is going to be very near for us, so we should be very alert. So whatever it is, everybody is doing their duty, and we, in our position, we are taking the students, we are supporting the students, we are as a educationist, as an academician, we are doing our best. So we as a academician, we should feel proud on our own. Okay, so we should not expect anyone to give appreciation from others. We should feel proud on our own. Okay. Okay, so without any delay, let me start the session now. Shall I present the screen, try?
Yes, ma'am.
Yeah, I'm started. Able to see my screen, ma?
Yes, ma'am. It's visible,
Oh,
ma'am.
okay.
Yes, ma'am.
Okay. So today I'm going to give one session, that is faculty development program session, on the topic natural computing ideas and challenges. Okay, so these are the contents: introduction, then computing, rules and ideas, philosophy of natural computing, followed by classification and three classes of natural computing, and finally the research focus on natural computing and future of natural computing. Before getting into the session, I'm going to request you for imagination. Just start your imagination following my words. Just 1.5 minutes, please. Imagine a world where computers can create new universes. And within this universe, there are natural forms capable of reproducing, grow, and adapt. The next thing, imagine natural patterns, mountains, ant colonies, immune system, brains, all learning and evolving and becoming more adapt to the environment. Imagine if our computer could contain new forms of lives, maybe we could automatically create house, music, design, new forms of protecting the computers against invaders, and new forms of computing and solving complex problems, etc. Just an imagination. Now stop your imagination. Welcome to natural computing. Okay, so that's what. Just perhaps introduction about nature computing. What is nature computing? In a simple way, we can say it is nothing but from nature to computing, natural computing. Very funny, right? Nature to computing. The transformation of nature to computing. That's we call it as nature computing. Okay. right? You can see in the picture here, you can see a lot of ants, and here also you can see some of the insects. And below the picture there are a lot of robotics like machines. They are going here and there. It is nothing but it is the one which we are grabbing from the nature. So this is a simple picture which depicts the nature computing. It's a simple formation, that's it. Okay. uh, Now natural computing is nothing but it is a phenomenon. For example, maybe a process, substance, organization, organisms that have a long inspired and motivated people to mimic, design, build novel system artigraphs. Starting from Isaac Newton till now, for many centuries, people are allowed to devise theories about how nature works. And before getting into a deep discussion about natural computing, I'd like to start with what is a computing. Just a small introduction about what is computing, then we can get into natural computing. Computing is any goal oriented activity. It should require a benefiting form or creating algorithmic process, and it should have three stages, that is three important things to be done. First one, designing, developing and building hardware and software system. The second thing, processing, structuring and managing various kinds of information. Obviously, if we have design, developing, building hardware, so a lot of things will be stored on that part. Automatically, that data should be managed in a better way. So in the second part, we should have some capacity to have, that is to manage those information. Finally, the scientific research has to be managed with computers. And we have lot of models from the earlier, starting from own Newman model, that is a very simple one, instruction driven model. uh, Normally we have no personal computer, whatever the instructions given it will follow, and accordingly it will react. And the second one, pattern driven model, where we have this artificial intelligence. And the third one, data driven model, we have machine learning, soft computing. Lot of researches are done in this area only, machine learning. And natural computing, actually this natural computing has started from the millennium itself, that is molecular computing, quantum computing, but still it is under evolving only. There is no research uh, that is up to date, that is people are very struggling to have lot of research under this area. So what is natural computing? Natural computing is a field of research that investigate the models of computation technique inspired by the nature, and dually attempts to understand the world around us in terms of information processing. It is highly interdisciplinary also. It is a field that connects the natural sciences with different aspects, that is with computer science aspects, both at the level of information technology and also at the fundamental research. And when discussing about natural computing, in a simple way, we can say it is nothing but it is a process of extracting the ideas from the nature to develop an artificial systems, that is computational systems, or using a natural media, for example maybe a molecules, to perform a computation. Okay, it is nothing but extracting the ideas of nature. From the nature we are grabbing something, and with that ideas we are going to develop something. Okay, so that may be an artificial one. That artificial means what? Here I'm telling, the artificial. So where it comes, we are telling it about a natural computing, natural computing. Where it comes artificial, that means that artificial here means only that the system developed or human made instead of made by nature. There is a difference between this human made and the made by nature. Okay, right. The next thing, um, that is history. Like this is something in 1940s, a study of automated computing. In 15s we have information processing. Like in 60s we have the phenomena of surrounding computers, and in 70s what can be automated, and in 80s again computation, a study of computation, and in 2000s a study of information process, both natural and artificial. They starts the natural computing era. And what is the role in having this natural computing in this computational era? Okay, that is about 2000. After 2000 only the emerging of natural computing starts. So in that, what is the role? So overcoming those challenges, two important benefits for this nature and computing. First one, we should rethink and redesign of computing. So before that, we have a normal design that does something. Okay, if we process something, it will give the result accordingly. But that should be a redesigning. That should be a rethinking. That is the difference we are expecting, right? So the second one, a new approach for interacting with and using the nature. Okay, these are the two roles that we are expecting from the natural computing. And this is a simple example where I found from the Google only. Um, See the beak of this blood train. This is a one which designed with the help of this kingfisher beaks. Kingfisher beak and this beaks are one and the same. That is, it was designed based upon this kingfisher beaks design only. And similarly, this architecture is designed based upon this this flower. And again, this helicopter like this one was framed based on this architecture. So these are the simple example which they have designed their equipments or machineries or buildings with the nature designs. Okay. The next one, what are the main ideas behind this? That nature has evolved through ages. So it is from the beginning only. We didn't have anything new. The nature is from the beginning. Uh, Example, nest building, nest cleaning, main sense, hearing, seeing, touching, everything comes under that nature. And finally, the computer algorithm based or inspired by nature have been developed for some time, either to model nature or to solve the complex real world problems. Finally, whatever it is, whatever the mechanism we want to achieve, or whatever the things we are going to do, the final thing is to solve some complex problems. Our final result should be to solve real world problems. So this is a multidisciplinary. Also, it is interdisciplinary. Why we call it as a natural computing in both sense? Natural computing is will have an impact on all these areas: biology, physics, chemistry, computer science, everything all together in natural computing. And combining all the concepts of physics, chemistry, biology, computer science, we can create some algorithms in natural computing that is called interdisciplinary. Nature computing has three classes of method. This is the main area where we are going to concentrate, and divided into three portions actually. The first one, computing inspired by nature. By looking into the nature, are going to analyze working mechanism of nature. Problem solving techniques can be developed. This is the first one, and the second one, simulation and emulation of nature. Uh, Here we are going to simulate or to create an artificial light out of it. We have virtual reality or animations like no. So it's all comes under the simulation emulation of nature. And third one, computing with nature materials. This is still under research only, very interesting and under development. This is the case that we are going to use the natural materials to work for us, developing algorithm with natural things. Okay, so this is about the computing with nature materials. So actually three categories in natural computing. So computing inspired by nature, and simulation emulation of nature, computing with natural materials. So let us discuss one by one. So natural computing with a new perspective, as we discussed already, natural computing. In the top, we have computer modeling of nature, and here, computer that is based on the classifications only. We have mentioned all these things. Nature inspired computing, computing with new materials, etc. And this is a philosophy of natural computing. See, you can see from the picture, it is given very clearly. All the things has been covered: theoretical studies, natural materials, experimental studies, empirical observation. Altogether, we are getting new forms of synthesis nature, new problem solving techniques, and finally, new computing paradigms. And based upon this classification, natural computing algorithm, this computing can be divided into three categories, right? First one, second one, third one. First one, computing inspired by nature. Under that, we have evolutionary computing, swarm intelligence, artificial immune system, and artificial neural networks. And computing taking place in nature. There is a second one. We told no simulation and emulation. Like under that, we have two things: quantum computing and molecular computing. And below molecular computing, we have another two categories like DNA computing and membrane computing. And simulation of nature phenomenon in computer, we have fractal geometry and artificial life. This area is still under development only, completely mathematical concept, that is fractal geometry, but very interesting. First one we are going to have, so in this 1 hour we cannot concentrate on all the areas in natural computing. Very few computing areas I'm going to give very short description. Let us see. Swarm intelligence. First, swarm intelligence is one of the computational intelligence techniques which are used to solve complex problem. And it is a very emerging field. Now we have a lot of uh, research areas under swarm intelligence only. Inspired artificial intelligence based on the behavior models of social insects like ant, bees, termites, etc. And swarm intelligence involves collective study of individual behavior. Population interacts with one another locally, and there is no centralized one here. Agents only controlling each and every one, so there is no centralized control over the structure. So this is about the swarm intelligence, and we looking at this picture. It is based on the collective social behavior of organisms, and we have all these algorithms under swarm intelligence. ACO, that is ant colony optimization, particle swarm intelligence, like very interesting one. Particle swarm is a reactive search optimization, kill herd fish, everything. All this comes a bat algorithm. See, from most of the organisms, we are getting something out of it. It is a multi-agent approach may allow for the better exploration of the space. Simple agent together can perform complicated tasks. It may be easier and cheaper, right? And the scope, that is swarm intelligence scope, is under three categories. We have still more number of research areas are there: search and optimization, data analysis, and robotics. Key capabilities of swarm intelligence of we have given only four: scheduling, optimization, routing, and clustering. Here, the first one is scheduling or load balancing. Here, the emphasis is on the relative position of the job rather than the direct precedent or the direct successor of the schedule. Okay. The clustering, we know very well what is a cluster. And a cluster is a collection of agents which are similar and are dissimilar to agents of other cluster. Optimization is a problem of finding the best solution out of the feasible ones. Routing, best route out of the it is like most of the routing algorithm will be based on ants only. We know we are in our real time self day to day we are seeing a lot of ants going here and there. No, you can see the routes how they are following from one place to another. So from there they have find out this swarm intelligence on ant as a base, routing as a base. Okay, this is based on principle that backward ants utilize the useful information gathered by the forward ants on their trips from the source to destination. Okay, so why we have to go? See, all this are possible with our normal things also. Why we need to go for swarm intelligence means these are the things: robustness, flexibility, easy marketing and implementation, low total cost. For these reasons only, we are getting into swarm intelligence. So flexibility, the colony respond to the internal disturbances and external challenges also. Robustness, if anything happens, it will not stay as it is. It will go as that is with the help of the other one. Because it is not a centralized one. That's why this robustness is possible. And scalable, decentralized, okay, self-organized. These are the characteristics of ant. You can see, well, an ant is traveling from one place to another. These characteristics will be followed by the ants only: adaptation, speed, modularity, and parallelisms. Applications of swarm intelligence. Um, this is a very earlier one. There is US military is investigating swarm intelligence for controlling unmanned vehicles. NASA is investigating supplanetary mapping. In 1992, control nanobots with the body of purpose of killing the cancer tumors. And in Disney, this most of the people have saw this films, no, Lion King and Lord of the Rings. So in that movies, they have used this swarm intelligence for having that mass uh, scenes like wild beastly scene, right? In such things, they use the swarm intelligence to have uh, a illusion like looking like a lot of people are residing at one place. Then swarm technology is particularly attractive because of the cheap, robust, and simple. And these are some of the frameworks available for that is swarm intelligence. The general modeling framework for swarm. This is for research and swarm intelligence, the moving agent, a model for simple reactive agents, and ASSL, automatic system specification language for generating automatic systems, and swarm organs for gene regulatory network controlled agent, and dynamic data driven application system for artificial swarm control. It is one which has the ability to dynamically incorporate additional data into the executing application, and then reversibility of application to dynamically steer the measurement process. And we have some I have mentioned very few swarm languages like protoswarm, swarm, growing point language, star logo. These are some of the famous swarm intelligent languages used nowadays. Very simple examples where swarm, that is applications where we are using swarm intelligence: swarm robotics, Bluetronic swarm mobile ad hoc networks, robust, flexible, easy to use swarm energy management. Okay. The next one is artificial immune system. It's a field of to concern with abstracting the structure and functions of immune system, computational system, and investigating the applications of the system towards solving computational problems and mathematical engineering and information. This is completely about the immune system. So its application covers computer virus detection, anomaly detection, time series of data, pattern recognition, as usual, bioinformatics, optimization, robotics, and controls, and DNA computing. The next one is about the DNA computing. Here, before getting into DNA computing, everybody should know what is DNA, because then only we'll get some idea. Maybe we could cross this things in our schoolings, just a recollections of everything. Every single cell which build up a living organization carries information for various function necessary for survival of the cell. This genetic information in each cell is stored in a molecule called nucleic acid that we know very well, right? Then the most stable form of nucleic acids is called um, decycloproleic acid, that we call it as DNA. Then each DNA strands form helical structure that we know very well. This is a structure, right? See, helical structure. Two strands mingle together. ஒன்னோட ஒன்று பின்னின மாதிரி இருக்கும்னு சொல்லுவாங்க நம்ம. அது வந்து நான் சொல்லுவேன் helical structure. Okay, that are long polymers of the millions of linked nucleotides. And these nucleotides consist of one of the four nitrogen bases, a five carbon sugar and phosphate groups. So these are some technical things, the biological things. And nitrogen base, that is nitrogen base means we have under nitrogens we have four, that is adenine, thymine, guanine, and cytosine. That is, in short, we call it as ATGC. Okay, so this ATGC, this four things are very important in this strands. The remaining will deals about the structure. Okay, so the strands are linked together by ways of pairing rules, and T with A, C with G again. This arrangement of this base is important as they decide the functionality of different genes. Okay, so this DNA is very important for our human beings, for any not only for human beings, any organisms in this world. When taking into the idea, that is looking at the idea of these two strands mingled together, right? But the four things T, G, C, everything together, they form some strands. So this is the base for DNA computing. So DNA computing is an area of natural computing based on the concept of performing a logical and arithmetic operation using molecular properties of DNA by replacing the traditional carbon silicon chips with biochips. So instead of silicon chips, nowadays they are using biochips. Okay. So the concept of this DNA computing was first introduced in 1994. It deals with biochips made of DNA that are able to perform billions of calculations at once by multiplying themselves in numbers. So that multiplication is a plus for this DNA computing. In other words, it computes, grows as it computes. Yes. In the recent developments, the researchers from the University of Manchester have shown that the creation of this conceptual computer is possible in real life. These are some of the applications of DNA, implications of mathematics, and implications of computer science and engineering, and also in medicine. It has that is for monitoring the patient conditions. We are using this in DNA computing, and we have DNA chips, cryptography, genetic programming, medical applications, cracking of code messages, DNA fingerprints. In all this application has an impact of DNA computing. And if we get into advantages of this DNA computing, that is DNA computing, and with this computing they are developed from computers also. Where main three benefits of this DNA computing is performance rate, parallel processing, and ability to hold tremendous amount of information in very small space. And it consumes very low power also. When it comes to a DNA computer, it consumes very low power. And if it is in computing, we have three important benefits. For example, if we consider performance rate, performing millions of operations simultaneously allows the performance rate of DNA strands to increase exponentially. The Alderman's famous researcher, its experiments was executed in that is 1940 operation, that is with 1014 operation per second, a rate of 100 teraflops. It means that 100 trillions of floating point operation per second. The world, even see, when if it compared with the supercomputer, fastest supercomputer runs at 35.8 teraflops only, but this DNA can perform 100 teraflops, okay, per second. So see the difference between uh, the supercomputer speed and the teraflops for DNA computing speed. Very terrific. Okay. Then parallel processing. When it comes to parallel processing, that is one of the important benefit of DNA computing. The massive parallel processing capabilities of DNA computing has potential of speeding up the large but otherwise solvable and polynomial time problems, resigning relatively few operations. For instance, let us consider a mix of 1018 strands of DNA. Okay, so 1018 is an example I found from a YouTube channel. 1018 strands of DNA cloud operate at 100,000 no, 10,000 times that speeds stored today advanced supercomputer. So when compared to the advanced supercomputer, it speeds up 10,000 times more than that. Okay, so in that mode also it feels very better than the normal things. And the third one, ability to hold a tremendous amount of information in a very small space. The storage area. Okay, this is concerning about the storage area. That is traditional storage media such as videotapes requires 100 to the power of 12 cubic nanometer of space to store single bit of information. But when it comes to DNA module, it requires just 1 cubic nanometer. So here the difference is a major thing. 1 cubic nanometer is very less when compared to 10 to the power of 12 cubic nanometer. Okay, so these are some of the benefits of having the DNA computing. And if we compare this DNA computers with conventional computer, we have, as we discussed earlier, we have advantages and also we have some disadvantages also, like setting up of a problem make a considerable preparation. This is a disadvantage of DNA computing. And the chemical destruction. It is very sensitive for chemical destruction, whereas it is not an issue in conventional computers. The next one, evolutionary computing. So, excuse me. Okay. So the computer is a normal thing. Already we have discussed these things. So there are some limitations. Whatever the computing is, so still now we have seen something, right? Artificial immune system, swarm intelligence, or collectively called as natural computing. We have some drawbacks at the existing conventional systems. That's why we came into the new concept of unconventional systems, right? Okay, so what are the limitations? Means we have listed something. The convergence of optimal solution depends on the chosen initial point, and most algorithms tends to stuck up on suboptimal solution, and depends upon the nature of problem. Algorithms are not efficient in handling discrete optimization problems. Cannot be efficiently used on parallel machine. I think most of the researchers would have crossed these types of problems in your research also. So what are the we have some innovation techniques for optimization. Many innovative ideas from nature has been evolved by the mathematicians to develop new and efficient techniques. This is particularly for optimization and colony optimization, computer virus, immune system, genetic algorithm. All this comes from this nature computing only. And a simple description about the evolutionary algorithm. See, from the present generation, selection was made by, and then given to selected parents. Then the parents will take that pairs, and it will give they will give some variation and mutations. After that, it will be given to new generated with a new generation, and it will be replaced with the present generation. Again, this will continue again and again. Okay, so how does it works? Initialization, evaluate, terminate, selection, variation. First initialization, for example, let us consider 10 players, for example. Okay, it is not actually, but for example, I am discussing you. Let us consider 10 players. First, we are taking 8 out of it. Then we have to evaluate, getting into evaluate stage. So we are evaluating all the 8 players, and we have to notice their height, weight, or what is the capacity of the person, that they whether they have any difficulties, or what are the plus and minus of the players. Like we are evaluating in different sense about each and every one in the 8 and with the entire team. Okay. Okay, after evaluating the persons, whether we after having some experiments, they can decide whether we can have the person or we can eliminate. That is, whether we can continue or we can terminate. If so, um, based upon what we are going to terminate the person. The next one, if you are going to, for example, if I am going to terminate one person out of 8, then again I have to go for selection. So reservedly we have two more person in our team. That is, initially we have 10 count, right? So additionally we have 2. So out of 2, again I have to do one selection. So based upon the criteria whichever we have evaluated with the 8, with that criteria I can choose any best one out of 2. Okay, so from the patterns which I developed, from the knowledge whichever I grabbed from the evaluation of the first stage, I can choose the better one from the 2. Okay, there again with a variation, I am going to get into another evaluation stage. Again, it will repeat again and again until a best things going to be evolved. Next one is membrane computing. Uh, George Pan is the father of membrane computing. A, a statement given by a Pan. The paradigmatic idea of membrane computing is to see whether we can mimic the living cell, its structure and functioning. Yes, the living cell have usually a large number of compartments hosting a huge variety of biochemical reactions. So inside cells we have membranes, right? That's why the statement was given by the Pan. So a living cell is doing computations too. This membrane computing is an area within a computer science that seeks to discover a computational model from the study of biological cells, particularly the membranes. And this is a branch of molecular initiated by the George Pan in 1998 itself. Next one, artificial life. This is a final classification. That is final. I told you, right? There are 3 classification out of computer with nature material is still under development, and it is very interesting. But I have given very few slides for artificial life. Artificial life is a research field whose ultimate goal is understand the essential properties of life organism by building within electronic computers or other artificial media ab initio systems that exhibit the property normally associated only with the living organizations. Earlier example include that is the L system that have been used for model plant growth and development. Um, the field of synthetic biology explores biological implementation of similar ideas, and you would have crossed this thing earlier. Artificially, the people are growing the plants without any uh, that is base. Usual things we are feed. No, we have to feed the plants. So without any things, the plants can be grown. The research focus on these areas is a sentimental analysis, word sense disambiguations like. And the future of natural computing is a great challenges for the field is transforming in the natural computing into transdisciplinary discipline and unveiling the harnessing information processing in natural system and engineering natural computing system. These are some of the challenges they are facing. And thank you so much. Thank you.
Thank you, ma'am.
Thank you.
Participants, if you're having any queries, you can unmute and you can ask your queries. Thank you, ma'am. Nadia, ma'am.
Yes, ma'am.
Ma'am, you can continue.
Okay, ma'am. Good morning, one and all present here. Certainly, I hope this session is very useful for all the participants. I would like to thank our honorable resource person, Dr. D. Aguila, Associate Professor, Wells Institute of Science and Technology, for taking out from her busy schedule to be with us here today. And she has sharing natural computing ideas and challenges and detail explain swarm intelligence techniques and all. It is very useful for all research scholars where everyone participates actively. Thank you for giving the wonderful session, ma'am. I would like to thank our beloved principal and head of the department, Dr. V. Uma Devi, for their blessings and support to arranging this faculty development program. And I also thanked all the participants for joining this session and enjoy the time of learning. Thank you.
Thank you, Nadia, ma'am.
Thank you, ma'am.
Ma'am, Akila, ma'am. Thank you, ma'am.
Thank you.
Agila, ma'am, could you please switch on your video, ma'am? We can take the photo, ma'am.
Thank you so much for the management and the department who gave me the chance to participate in this FDP. Thank you everyone for your patience. Thank you so much. Am I visible, ma?
Yeah, ma'am.
Yes. Yes, ma'am.
Okay.
Okay, ma'am. Thank you, ma'am.
Thank you. Thank you so much. Thank you, Kalisa
Thank,
ma'am. Thank you, Nadia.
thank
Thank
you,
you.
ma'am.
Thank you.
Thank you, ma'am.
Oh, thank you, Maha. Thank you, Da. Thank you. Shall I move now?
Yes, ma'am. Yes.
Okay.
Thank you, ma'am.
Thank you.
Thank you
Thank
for coming, ma'am.
Yeah, sure. Thank you.